There are 9 basic rules of probability which taken together should help us solve most probability questions. And the first basic rule is that all probabilities lie between 0 and 1. So for example, if you have a probability of event A occurring, it's going to be somewhere between 0 and 1. And if it's certain to happen, its probability is 1. If it's certain not to happen, its probability is 0. The second basic rule is that if you look at all possible events in a random variable, their sum must equal 1. So if, for example, if there are 26 possible outcomes in an event, the probability of the first plus the probability of the second, all the way down to the probability of the last, have to total 1. And then a definition that can often be helpful in solving probability questions is the complement. And the complement of an outcome is everything except that outcome itself. So the probability of the complement of event A would be 1 minus the probability of A itself. And I'll give you an example. The complement of at least 1 is none, because taken together they cover all possibilities. So mathematically, the probability of at least 1 is the same as 1 minus the probability of none. And it's often easier to attack this probability than it is the other. So keeping complements in mind can be a valuable problem-solving tool. Next, if you see or in a problem, it means add. For example, the probability of A or B occurring is the probability of A plus the probability of B minus the probability of A and B. And we have to subtract this part because we want to avoid double counting people who are in both A and B. Here's an example. Suppose we want to know the probability that a random HB student is taking statistics or French. Well, we want to get the probability that they're taking statistics and add to that the probability that they're taking French. But we've now double counted people who are in both categories, so we subtract away that overlap once. And this is an image, a Venn diagram that sort of shows that occurring. Now, it's possible that you have no overlap. So it's possible that there are no students taking both statistics and French. And if that's the case, you say those two events are disjoint. And it simply means that the probability of them both occurring is equal to 0. Also, if you see the word and in a probability question, it means multiply. The probability of A and B occurring is the probability that A occurs times the probability that B occurs given that A occurred. And that vertical bar there means given that. It's a conditional probability. Now, it's possible that the probability of B doesn't depend on A. And if A and B are independent, then knowing that A occurred doesn't change the likelihood that B occurs. And in that case, written mathematically, the probability of B given that A occurred is the same as the probability of B. Next, let's look at factorials. In probability, we use factorials to calculate the number of different ways to order a collection of items. So, for example, suppose we have 8 Olympic sprinters on a track, and we want to organize them in the different lanes. We actually have 8 factorial different ways of organizing them. And 8 factorial means 8 times 7 times 6, all the way down to 1. And your calculator can do that relatively quickly, and it turns out that there are 40,320 different ways to order those 8 Olympic sprinters. It's kind of impressive. And in general, the number of ways to order a collection of n items is n factorial. Next, let's look at permutations. Suppose that we want to select a subset of items from a collection, and the order in which we select them does matter. For example, using these sprinters again, if we have 8 sprinters running in the finals, and we want to know the number of possible gold, silver, and bronze outcomes that we could get, that calculation will be 8 factorial over 5 factorial, which gives you a grand total of 336. The way I like to look at that is 8 factorial is the number of different ways that the 8 runners can finish, but we don't care about the order of the 5 finishers who don't get a medal, so we divide by that 5 factorial, and that gives us 336. In general, if you're selecting k items from a collection of size n, and the order of those that you select does matter, then the number of possible outcomes is a permutation, and it's n factorial over n minus k factorial. Next, let's look at combinations. And combinations occur when you select a subset of items from a collection and the order doesn't matter. So for example, suppose that we took those 8 sprinters from before and we just wanted to grab 3 of them to serve on a committee. The order in which we select them doesn't matter because it doesn't make a difference whether we select A, then B, then C, for example, or B, then C, then A. So if order doesn't matter, the number of different outcomes is going to be 8 factorial over 3 factorial times 5 factorial, which is only 56. Again, the way I like to look at it is 8 factorial is the number of different ways you can order the 8 people, but we don't care about the order of the 3 that we select, and that's what's causing the 3 factorial down there. And we also don't care about the order of the 5 that we don't select, and that's the 5 factorial. So our answer is only 56. We're going to use combinations a lot this year. And in general, if we want to select k items from a collection of n and order doesn't matter, then we're going to use this formula. It's going to be n factorial over k factorial n minus k factorial. And there's several ways that this shows up in writing and also on your calculator. And you want to make sure that your calculator notation is something that you're comfortable with. But this is a combination of n choose k. It can be written several other ways. And then mathematically, that's what it looks like. So the final piece of advice I have for you on solving probability questions is to always draw a diagram. Diagrams are incredibly helpful at sort of making sense of the different scenarios that are at play in a problem. And in our unit, we'll be using Venn diagrams, like those circles that you saw before. We'll also be using two-way tables, and finally we'll be using tree diagrams. And we'll practice those in class together.